When cells join together, they form tissues. And that's what this section is about. And there are 4 basic types of tissue. Today we're going to talk about epithelial tissue, which is one of the 4. Epithelial tissues are the surface tissues of skin, all body cavities including glands, ducts, and vessels. The job of epithelial tissues is to secrete and absorb and protect. Let's go over the different types of epithelial tissue. The types are simple, stratified, and glandular epithelial tissue. Each one of these types, simple, stratified, and glandular, have subsets. For example, simple consists of squamous, cuboidal, and columnar, and pseudostratified columnar epithelium, while stratified contains stratified squamous and transitional. Glandular epithelial consists of exocrine and endocrine epithelia. Let's start by reviewing simple epithelia. As I stated, simple epithelia consists of squamous, cuboidal, and columnar, as well as pseudostratified columnar. Squamous epithelia is flat. By the way, simple epithelia means one layer, a single layer. Very, very thin single layer. Now, simple squamous, you see how flat these cells are. This is a cell here, this is a cell here, and this is a cell here. Look how flat and squashed they are. And that's how I think of, remember, squamous epithelium by the prefix squa or squam. It's flattened. And what makes simple squamous epithelium effective, what it does is it's so thin that it allows for diffusion of particles, of chemicals, of products to go through the layer because it's so thin, and it's perfectly set up for that. Simple squamous epithelia are found in the lining of the heart, one sec here, in the lining of the heart, where is it? There it is. Lining of the blood and lining of the lymphatic vessels, air cells, body cavities, and glomerulus in the urinary tract. That's simple squamous epithelia. Simple cuboidal epithelia are different in shape, as you notice, as the name indicates. Cuboidal, look, they're cube-shaped. Or at least they're not flat-shaped like squamous. And what do you think the function of a more cuboidal cell would be? Would it be to allow products to pass through it? No, I don't think so. Rather, you can see by their increased shape, they're voluminous. They have more volume than the squamous. In other words, they can absorb and secrete fluids and products in the body. Simple cuboidal doesn't do much absorption, actually. They are more concerned with secretion. products that the glands make, like hormones, will be created in these cubes here, and then they will be secreted out to the body. Next, simple columnar epithelia. Simple columnar. Well, you can see why these are called columnar, yes? Because they're shaped like columns, not cubes, but columns. Let's see here. Let's do better. See these columns here. These are simple columnar epithelia right here. Columnar. Of course, cuboidal, the previous. These columnar epithelia are, you see how they have great volume in there. They can carry a lot of fluids. So they are created for, and what they do well is they absorb and secrete. As I was discussing with the cuboidal, simple cuboidal, they mostly secrete products that are made inside of these little cuboidal cells. But the simple columnar absorb and secrete. Simple columnar epithelia are found in the intestines, in the gastrointestinal tract. You see here. This is inside of your gut, where food is absorbed and other products are secreted, like mucus. Now, something interesting on the columnar epithelia, they have these little hair-like projections on here called microvilli or villi. And what these projections do, if you were to look at them real close, they would look like this. And if you can imagine these finger-like projections coming up, and look at the surface area along the outside, what the microvilli do is they increase the surface area so that more secretion and absorption can take place. Now, we talked about how simple epithelia have one layer of cells. Squamous, simple cuboidal, and simple columnar, all one layer. Well, look at this new guy here called pseudostratified columnar epithelia. Well, it kind of looks like columnar, but it looks like multiple layers, doesn't it? Well, that's an illusion. Pseudo means false. See, here's one cell right there, and you can see it reaches from top to bottom, creating one layer. Here's another cell right here from top to bottom. So it's false stratified. Pseudo-stratified means, well, strata means layers, okay? So it's false layers of columnar. In truth, it's a single layer, but it just appears to have many layers. Notice on top of the pseudostratified columnar epithelium is these little finger-like projections here. They're not microvilli, they are cilia. And the purpose of these cilia, these little hairs on top, is not like microvilli to increase the surface area for absorption and secretion. Actually, these little hairs, what they do is they move particles. They move in a wave-like fashion. And then what they can do is move particles with a wave action along the surface of the epithelia. So you can see the pseudostratified columnar epithelia appear stratified or to have layers, but they're not. It's just one layer. And where you find these are in the reproductive and respiratory tracts. And here's the description of the cilia, where they collectively move surface material with the power of the like a rowing motion of the cilia, those little hair-like projections. Stratified epithelia. Well, we talked about the word strata. It means layers. Layers. Strata is a layer. So stratified epithelia would mean what? It would mean layers. Multi-layered epithelia. Not a single layer like simple, but multi-layers, many layers. And sure enough, that's what we see right here in the stratified squamous epithelium. Notice stratified squamous, meaning many layers. And what about squamous? Squashed, right? And here they are right here. Stratified and flat. A correction here. The stratified squamous epithelium is these ones on top here. Notice how they're squashed and flat like simple squamous epithelium up here. But there are more than one layer. So that's what your skin, the outside of your skin, is made of stratified squamous epithelia. See, they are flat, squamous, on the tissue surface. In the skin, as is in this case, they are keratinized. They have a protein in them called keratin that makes them tough and strong and protects your skin from invasion. They're also found in the oral cavity, the mouth, the esophagus. Now, as you go deeper in the skin, the cells are columnar, but at the top of your skin, they are flat, squamous. The second type of stratified epithelial tissue is called transitional. It's called transitional because it can stretch and get from bigger to smaller. Number one, there are multiple layers, as you can see, here and here. So they're stratified, and they're transitional because they can change shape. For example, in the urinary bladder, here, when your bladder is full of urine, it gets bigger, and that stretches out the outer layers. And when they stretch, they become thinner. The layers become thinner, as you can see right here. But when your bladder gets smaller, the layers remain thick. When it stretches and it's full of urine, it's thin, like this, distended. When your bladder is relaxed and small, the outer walls are thick. But when it fills up with urine, it stretches and becomes distended and thin. So, as you can see, it's easy to tell why it would be called transitional epithelium, because it goes from transition to, from thin to fat, I guess you could say. Thin when the bladder's filled up with urine and it stretches, and then thicker as the bladder is relieved and as the bladder empties and the walls become thick again. So again, a relaxed bladder would have thick walls like so. And then when it fills up with urine, the walls would thin out like so. And the epithelia would go from a thickened state to a thinned, flat-looking state. The last type of epithelial tissue is called glandular epithelia. Well, it's called glandular for obvious reasons because these epithelia are found in the glands of the body. Glandular epithelia. Here's a gland right here. It's either let's say it's a sweat gland. Well, the sweat gland is an exocrine gland. Exo meaning outside of. Because what the sweat gland does, these glandular epithelia, well, they make sweat. They're like little sweat factories, and they put their sweat in this little duct, which goes to the outside. That's why it's called glandular exocrine epithelia. Exocrine glandular epithelia. Now, here's an example of the thyroid gland, the cells inside the glandular epithelia tissue inside the thyroid gland, which is an endocrine gland. So it contains endocrine glandular epithelia. Why endocrine? Well, endo is the opposite of exo. It means within or inside of, because these glands make their thyroid hormone and they dump it into this little blood vessel right here, which dumps into the blood circulation. It stays inside the body. Whereas, say, a sweat gland or a sebaceous gland, which is the oil, which secretes oil on your skin, or sebum, puts its products outside of the body, outside of the skin. And so this is your exocrine epithelia, glandular epithelia, and these are your endocrine glandular epithelia. Some exocrine glands, as we talked about, are sweat, sebaceous gland, the oils on your skin, pancreatic, and mammary. Mammary is the breast, the mammary glands of the breast tissue. And like I said, they put their products outside of the body. Sweat, sebum, etc. Endocrine glands put their products inside the bloodstream is what they do, instead of outside of the body. For example, hormones, as we discussed here, thyroid hormone. So there you have the different types of epithelial tissues. Review. Simple epithelia, squamous cuboidal columnar, pseudostratified columnar. Stratified epithelia, stratified squamous and transitional. And glandular epithelia, exocrine and endocrine.